So now we can look at this as a decision problem, and we'll call it the long and simple path decision problem. And it goes like this. Given a graph G and a length L and two nodes U and V, is there a simple path from U to V consisting of L or more nodes? So we're not looking for a short path, we're actually looking for a long and simple path. And we're going to imagine, and I'm saying imagine because I actually don't know whether this is true or not, but we're going to imagine that there's an algorithm that solves this decision problem. It says yes or no correctly, and its running time is n to the k for some constant k, like 2, so big theta of n squared, or 10, like big theta of n to the 10th, or 1,000, big theta of n to the 1,000, but k is not a function of n. So it can't be an exponential or it's got to be bounded by some polynomial. It could be a nasty polynomial, but let's just imagine that it's bounded by a polynomial. All right, now here's a different problem. Find a simple path from U to V in G consisting of L or more nodes. So this one is just asking the yes-no question. This one's actually asking for the path. And we'd like to know, is there a polynomial time solution to this problem? We'll call it problem B. Assuming that there is a polynomial time solution for problem A. We can use the solution of problem A as a subroutine in solving problem B. All right, so here's how we'd like you to do it. I want you to write a Python command called long and simple path that takes a graph G and node U, node V, and a length L. And it's allowed to call long and simple decision with whatever it wants as many times as it wants, as long as it's a polynomial in the number of nodes and edges in the graph, and ultimately return the path if there is one. So here's a little skeleton to get you started. We call long and simple decision G, U, V, L, and if it's the case that the decision problem says, or the solution to the decision problem says there is no path of length L or greater from U to V in G, then you don't have to do anything, just return false. But otherwise, you actually need to build and return the path as a list of nodes. And the first element of that list should be U, and the last element should be V, and all the steps in between should be actual edges, and the total number of nodes on that path needs to be at least L.